the from is the unique identifier that is associated with that user. And then all of the set of twos that are associated with that particular from ID are all of the attributes and all of the links of that user. So basically, your select query for that user would be, get all of the rows that have this from ID value. And if you wanted to look at all the backlinks, so if you wanted to look at all of the things that pointed to a given user, you would say, give me all of the rows where the to ID is equal to this ID number.
So each piece of information of the user, it will have its own.
It had its own row, yeah. Yeah, and basically that it came from the philosophy that that the link was sort of the most important thing that we wanted to deal with in the social networking context. And that scaled really well to 40 million active users. We've and also it was very easy to partition. We didn't have a lot of different tables that we had to figure out how to partition. We just had one big table that we partitioned as new users came on board. So again, if you come up with a simple design, it sometimes it buys you a lot as time goes on.
But then when you're like updating it, don't you have to lock the whole table, or at least that's
okay. So we're coming to that. In a social network, by and large, the idea is that there's an owner to every single piece of data, and the way we defined it was so a user is the owner of their own account information, and then a user is owner to any object that they create in the system. So if you were to upload a video or a playlist on IMEME, then that object that you just created would be owned by you, and you'd really be the only entity on the system that had write permission on it. So we came up with a model where database rights were pretty much restricted to the user who created the object. And we had a mechanism for people to sort of give their objects to other people, or assign ownership to other people, but it was not really something that became a much needed feature. It was much easier just for users to copy content that others had. So, and we're going to talk a little bit more about that. The rest of the class is really going to look at the problems of multiple writers and stuff like that. In particular, two applications that are significant are Wikipedia and Google Docs, because both of those have slightly different models for allowing multiple people to write, and they each have various issues in allowing that to happen on the web. Yeah. So for user-generated data, I really recommend coming up with a very simple model of what's your most primitive data item that you really want to support well on the system, and then how are you going to aggregate groups of those data items to generate pages. Because if you do that in an interesting and intelligent way, it becomes very simple to start building pages for just about any application. So within IMEME, a page that allowed you to sort of edit your playlists was constructed very much the same way as the page that allowed you to edit your profile information. It's just that it was visualized slightly different. So the presentation layer was different, but all of the data requests were exactly the same, ultimately. Okay. And maybe that's another motivation for having all of your data requests return sets of things as opposed to individual items. Yeah, so we came up with a presentation mechanism also that was very efficient. We basically had this idea that in a user-generated environment, user-generated data environment, that there'd be a display mechanism for an entire profile, and then there'd be a display mechanism for kind of an abbreviated profile, sort of like a snippet or a paragraph that was associated with a given object, and then a display mechanism for just a link to that item. And so starting from that point, we were able to kind of construct all of the other types of displays, because we could distinguish for a given type of object. We want the main display functionality to look like this, the short display functionality to look like this, and link display functionality to look like this. So as we added new types into the system, we didn't really have to generate new tables on the back end, just new presentation mechanisms on the front end. And our query mechanisms, by and large, stayed the same. So to me, what that means from a scalability standpoint as coders is that you're mostly working on changing one particular layer as opposed to multiple different layers in the system every time your service undergoes a new functionality addition. Okay, so now I'm going to jump back from the various types of APIs and look at different ways you can use that data.